Many people, maybe you included, are fascinated by space rockets and their ability to fly out of our beloved planet Earth. These huge flying vehicles have only been around for not so long. The first launch was about 70 years ago. But how do rockets launch? And why do they take a certain curved trajectory? In the beginning of a rocket's launch, its engine undergoes the process of combustion, which is a process where fuel is burned to produce lots of energy. This combustion releases immense amounts of exhaust gas that has an enormous weight. The exhaust's weight is a force from the rocket on the ground below it. Thus, according to Newton's third law, the ground pushes up the rocket with the same weight that was exerted by the exhaust gas. This reaction force is called thrust. The ground is so big that the large weight of the exhaust gas has a negligible effect on the ground. But considering the fact that the rocket's mass is much smaller than Earth, the thrust acting on the rocket is enough to make it launch with great speed. Now that the rocket has successfully initiated its motion off the ground, it needs to take the simplest, fastest, and easiest way, which uses as little fuel as possible to get into orbit around Earth. A rocket can hardly get into Earth's orbit by going straight up, but to achieve this goal, a rocket must initially launch with a certain small angle, such that when it starts its motion upwards, gravity affects it, forming a slight curve in the path the rocket takes. You can think of it as similar to the parabolic shape formed by projectile motion. This curve grows larger as the rocket attains a higher speed and gets further away from Earth, so that once it arrives at the desired orbit position, it will have tilted as much as it needs to successfully orbit Earth. But what is an orbit? It's the curved path around a planet, moon, or sun. It is positioned at a place where the Earth's gravitational force is equal to the force caused by the rocket's constant rotation that allows it to follow a curved path. When these two forces are equal, their net force is zero. So, according to Newton's second law, the rocket can't fall back to Earth, but it stays in orbit. Aside from that, we want to question, why do we send rockets into orbit anyways? Rockets are launched for several different reasons. Two of those reasons are to send satellites into orbit, and to send space shuttles and astronauts. Many believe that rockets can't move in space, or vacuum, where there is no air. Well, actually they can, because the principle upon which rockets were built depends on Newton's third law and the presence of forces, not air. Indeed, this point particularly is what differs a rocket from an airplane. Rockets don't depend on air and can move in vacuum, whereas airplanes depend on air and need oxygen to fuel and fly. That's because the oxygen needed to complete combustion in a rocket is already packed and put inside it, whereas an airplane takes the oxygen it needs from the air around it. What we have so far discussed applies mostly to rockets used to get to space, but rockets can be used in many other different fields, mainly using the same principle of Newton's third law to launch them. Some of these fields include weaponry and fireworks. Coming to an end, here's a little question for you. How much time do you think a rocket needs to reach space? Leave your answers down in the comments to let me know your answer. Like, subscribe, and share to support this channel.